Welcome, dear listener. Tonight, we're going on a journey, not to distant galaxies or alien worlds, but right here, to Earth, the only home we've ever known. This planet beneath your feet holds more wonders than 1,000 science fiction novels, more mysteries than the deepest ocean trenches, more beauty than words can capture. But tonight, we're not here to be dazzled by spectacle. We're here to find peace, to let the gentle rhythm of Earth's facts wash over you like waves on a shore, to remember that you are part of something ancient, something vast, something quietly miraculous. So settle into your pillow, let your breathing slow, and let's explore the peaceful truths of our world together. If you enjoy these calming journeys, consider subscribing to Sleepy Science Channel. We're here every night, turning knowledge into tranquility. But for now, close your eyes. Let's begin. Earth rotates at 1,670 kilometers per hour at the equator. That's faster than the speed of sound. Right now, as you lie still in bed, you're spinning through space at supersonic velocity, yet you feel nothing. No wind, no motion, just stillness. Because everything moves together, the air, the ground, the trees, even the invisible magnetic field that shields us. The atmosphere travels with the planet like a blanket wrapped around a sleeping child. It's been this way for 4.5 billion years, spinning, silent, perfect. But that spin is slowing down. Every century, Earth's rotation decreases by about 2 milliseconds. Not much, barely measurable. But it means that when dinosaurs walked the Earth, a day was only 23 hours long. 600 million years ago, a day lasted just 21 hours. The moon pulls on our oceans, creating tides, and those tides create friction. Friction slows the spin, gradually, gently, like a top winding down over eons. What does this mean for you? Nothing immediate, nothing to worry about. In your lifetime, days will lengthen by about 1/50th of a second. You won't notice, but it's a reminder. Everything changes, even the fundamental rhythm of day and night. Yet, life adapts, always has, always will. Earth's core is as hot as the surface of the sun, 6,000 degrees Celsius. A ball of solid iron suspended in the center of our planet, surrounded by liquid iron swirling in powerful currents. This inner sun, buried beneath 3,000 kilometers of rock, generates the magnetic field that protects all life. Without it, solar wind would strip away our atmosphere. Water would evaporate into space. Life would be impossible. But the core is cooling. Every billion years, the inner core grows larger as liquid iron crystallizes onto its surface. The heat escapes, radiates outward, drives the movement of tectonic plates. Earth is a heat engine, slowly winding down, yet still powering mountains, earthquakes, volcanoes, and the invisible shield that keeps us safe. Think about that. The ground beneath you is floating. Earth's crusts, the solid rock you stand on, is only 30 kilometers thick in some places. Thinner than the skin on an apple, relative to the planet's size. And beneath that thin shell lies a churning ocean of molten rock, heated by the nuclear decay of ancient elements. Uranium, thorium, potassium radioactive atoms, forged in a supernova billions of years before Earth existed, are still releasing energy today, keeping our planet warm from within. You are standing on a thin crust above a nuclear furnace, yet you feel safe, secure, because Earth holds its violence deep inside, letting only hints escape. Hot springs, geysers, volcanic plumes, reminders that our planet is alive. Earth has 7 major tectonic plates and dozens of smaller ones. These massive slabs of crust drift across the surface at the speed your fingernails grow about 2 to 3 centimeters per year. In your lifetime, North America and Europe move apart by about 2 meters. Not much, but given enough time, continents collide and mountains rise. The Himalayas grow 5 millimeters taller every year. India is still pushing into Asia, still crumpling the crust, still forcing rock skyward. Mount Everest today is taller than it was when Edmund Hillary first climbed it. Not by much, just a few centimeters. But the mountain is alive in its way, growing, breathing with the slow breath of geology. One day, millions of years from now, the Himalayas will erode away. The mountains that seem eternal are temporary. Everything is. Africa is splitting apart. The East African Rift, a massive crack in the continent, is widening at about 7 millimeters per year. In 50 million years, a new ocean will fill the gap, separating East Africa from the rest of the continent. Madagascar did this already. It broke away from Africa 160 million years ago. Now it's an island, a world unto itself. Nothing on Earth is permanent. The continents drift, the mountains rise and fall, the coastlines shift. Yet for human life, for your life, these changes are invisible. The world feels stable, fixed, and in a way, it is. For 10,000 human generations, Earth has been stable enough for civilization to flourish. The climate held steady, the continents stayed put, and we built cities, grew crops, wrote stories, made art. But this stability is rare. For most of Earth's history, the planet was inhospitable, too hot, too cold, too violent. For 2 billion years, Earth had oxygen-free air, poisonous to us, methane skies, sulfurous seas. Then tiny organisms, Cyanobacteria, began producing oxygen as waste. These microscopic beings, no larger than a grain of dust, transformed the entire planet's atmosphere. They turned poison into breath, death into life. It took 1 billion years. Slowly, oxygen levels rose. Old life died, new life evolved, and eventually, complex creatures emerged. Every breath you take is possible because ancient bacteria worked for 1 billion years to prepare the air. You owe your existence to organisms that died 3 billion years ago. Earth's oxygen level is exactly 21%, not random. If it were 25%, forests would spontaneously combust. Lightning strikes would ignite infernos that couldn't be stopped. If it were 15%, fire couldn't burn at all. Animals couldn't get enough energy to move. 21% is the Goldilocks zone for complex life, perfect balance. And it's been stable for hundreds of millions of years. Who maintains this balance? Life itself. Plants produce oxygen. Animals consume it. Decomposers break down organic matter. The carbon cycle regulates everything. It's a self-balancing system, not designed, not planned. Just emergent complexity arising from trillions of tiny interactions. Earth doesn't need a thermostat. Life is the thermostat. The Amazon rainforest produces 6 to 9% of the world's oxygen, often called the lungs of the earth, but that's not quite accurate. The Amazon consumes almost as much oxygen as it produces. Old trees decay, animals breathe, microbes decompose. The net oxygen contribution is close to zero. So where does Earth's oxygen come from? The ocean. Phytoplankton, microscopic plants drifting in sunlight, produce 70% of the planet's oxygen. Invisible, uncelebrated, essential. One drop of seawater contains millions of phytoplankton, tiny beings, smaller than the width of a human hair, floating in the sunlit surface layer of the ocean. These organisms are the foundation of all life on Earth. They feed the fish feed the whales fertilize the ocean with their waste. The phytoplankton bloom, a cycle as old as the ocean itself. Earth's oceans cover 71% of the surface. That's 361 million square kilometers of water. If you melted all the ice on Earth and spread it across the planet, sea levels would rise 60 meters. Cities would flood, coastlines would vanish. But most of Earth's water isn't on the surface. It's locked in rocks deep underground. The mantle holds several times more water than all the oceans combined, trapped in minerals, hidden, waiting. Water is strange. Unlike almost every other substance, it expands when it freezes. Ice floats because it's less dense than liquid water. If ice sank, oceans would freeze from the bottom up. Lakes would turn solid. Fish would die. Life as we know it couldn't exist. But ice floats. It forms a protective layer on top of lakes and seas, insulating the liquid water below. Fish survive. Life endures. All because of one quirk of molecular physics. Earth's water is ancient. Most of it arrived 4 billion years ago, delivered by comets and asteroids bombarding the young planet. The water you drink today is the same water dinosaurs drank, recycled, purified by the sun's heat and Earth's rain. Water evaporates from the ocean, rises into clouds, falls as rain flows through rivers, returns to the sea. The cycle never stops. It's been running for billions of years without pause. Every water molecule spends about 3,000 years in the ocean before evaporating, then 9 days in the atmosphere, then weeks or months in rivers and lakes, then back to the ocean. The average water molecule has made this journey millions of times. It's touched every continent, fallen on every forest, been drunk by countless creatures. You are not separate from this cycle. The water in your body right now will soon return to Earth, and new water will take its place. Your body is 60% water, not by weight, by molecular count. You're 99% water. For every atom of carbon, nitrogen, or oxygen in your tissues, there are 10,000 water molecules. You are essentially a very complex arrangement of water, held together by a framework of organic molecules. When you die, the water returns to the earth. The carbon becomes soil. The minerals disperse. You rejoin the cycle that made you. But you're not just water and carbon. You're made of stardust. Literally, every atom in your body, heavier than hydrogen, was forged in the heart of a dying star. The iron in your blood, the calcium in your bones, the oxygen you breathe, all created in stellar furnaces billions of years ago. When massive stars exploded, they scattered these elements across space. They drifted, clumped together, formed new stars, formed planets, formed you. You are a temporary arrangement of ancient atoms. They were here before you. They'll be here after you. But right now, in this moment, they're organized into the pattern we call you. Conscious, aware, thinking, feeling, breathing. What a privilege. What an improbable gift to exist, to witness, to experience this universe from the inside. Earth is 4.5 billion years old. If you compressed that timeline into a single year, humans appeared at 11:58 p.m. on December 31st, All of recorded history, Empire Aurum, every war, every masterpiece of art happened in the last 10 seconds of the year. We are so new, so recent, yet we feel like we've been here forever. For most of Earth's history, life was simple. Single-celled organisms, bacteria, algae. For 3 billion years, this was all life was. Then, about 540 million years ago, something changed. The Cambrian explosion, a sudden diversification of life forms. In just 10 million years, most major animal groups appeared. Eyes evolved, shells formed, predators hunted, prey hid. Life became complex, seemingly overnight, geologically speaking. Why did it happen? Scientists still debate. Maybe oxygen levels reached a critical threshold. Maybe ocean chemistry changed. Maybe it was just time. Whatever the cause, life has been diversifying ever since. From simple worms to fish to amphibians to reptiles to mammals. Each form building on what came before. Evolution doesn't create from scratch. It tinkers with existing designs, modifies, adapts, reuses. Your hand has the same bone structure as a bat's wing, a whale's flipper, a horse's leg, 5 digits, wrist, forearm, upper arm. The same basic blueprint, modified for different purposes, because all mammals share a common ancestor. 300 million years ago, a small reptile-like creature gave rise to all modern mammals. That includes you. You're related to whales, to bats, to horses, to every furry creature on Earth. Go back further, and you're related to birds, to dinosaurs, to crocodiles. 600 million years ago, your ancestors were fish. The bones that let you hear the tiny ossicles in your middle ear were once gill arches in ancient fish. Evolution repurposed them, turned breathing structures into hearing mechanisms. Life doesn't waste anything. It recycles, reinvents, The deepest point on Earth is the Mariana Trench, 11,000 meters below sea level. If you dropped Mount Everest into it, the peak would still be 2 kilometers underwater. The pressure at the bottom is crushing, more than 1,000 times atmospheric pressure. Yet life exists there. Strange fish with transparent heads, amphipods the size of dinner plates, microbes that feed on chemicals seeping from the ocean floor. How do they survive? Adaptation. Deep-sea creatures have no swim bladders, fur-filled sacs that help fish control buoyancy. Air would compress under pressure, so these fish are filled with water. Their bodies are soft, flexible. They don't fight the pressure. They become part of it. A lesson in surrender. The deep ocean is Earth's largest habitat, 95% of the biosphere. Yet, we've explored less than 5% of it. We know more about the surface of Mars than we do about the bottom of our own ocean. Strange, isn't it? To live on a water planet and remain ignorant of most of its depths. But exploration is accelerating. New technologies, deep-sea submarines, remote porated vehicles. Every expedition discovers new species. Fish that glow, worms that farm, bacteria, coral that lives without sunlight. The ocean holds secrets we haven't imagined yet, and that's beautiful. Knowing there's still mystery, still wonder, still unknowns waiting to be discovered. Earth's magnetic field flips every few 100,000 years. North becomes south, south becomes north. The last flip was 780,000 years ago. We're overdue, some say, but overdue is a human concept. Earth operates on geological time. Flips happen when they happen. The process takes about 1,000 years, not instant, gradual. During the flip, the magnetic field weakens, multiple poles appear, compasses go haywire. Should you worry? No. Life survived every previous flip, tens of thousands of them. Yes, more cosmic radiation reaches the surface, but Earth's atmosphere absorbs most of it. Life adapts, always has. Birds that navigate by magnetism might get confused, but they'll figure it out. Life is resilient beyond measure. Earth's magnetic field is generated by the outer core, a swirling ocean of liquid iron, 3,000 kilometers below your feet. Electric currents in this molten metal create a magnetic dynamo. It's been running for 3 billion years, and it will run for billions more. As long as the core stays hot and liquid, we'll have a magnetic shield, and the core won't cool for another 4 billion years. We're safe, for now, for longer than we can imagine. Earth's atmosphere is held by gravity, not pressure, not containers, just the planet's mass pulling air molecules down. If Earth were smaller half the size, say gravity would be too weak to hold the atmosphere. It would drift into space. If Earth were much larger, gravity would compress the atmosphere. Higher pressure, denser air, harder to breathe. But Earth is exactly the right size. Goldilocks again, perfect by chance. Or is it chance? Some argue Earth's size is no accident. Larger planets form faster in the protoplanetary disk. They sweep up more material. But large planets also migrate inward toward their stars. Jupiter did this. It formed far out, then drifted inward, disrupting the orbits of smaller planets. Earth survived because Jupiter stopped. It reversed course, drifted back outward, left the inner solar system calm, enough for Earth to form in the habitable zone. We owe our existence to Jupiter's migration, a cosmic accident, a fortunate wandering. If Jupiter had continued inward, Earth might not exist, or it would be a barren rock or an ice ball. Instead, we're here, alive, conscious, wondering about our origins. Earth orbits the Sun at an average distance of 150 million kilometers. This distance is called 1 astronomical unit. Light from the Sun takes 8 minutes and 20 seconds to reach us. When you feel sunshine on your face, you're feeling photons that left the Sun's surface 8 minutes ago. You're looking into the past, touching history, experiencing a moment that no longer exists. If the Sun suddenly disappeared, we wouldn't know for 8 minutes. Earth would continue orbiting through space, following the gravitational curve the Sun created. Then, 8 minutes later, gravity would vanish. Earth would fly off in a straight line, into the cold, into the dark, into the endless night between stars. But the Sun isn't going anywhere. Not for 5 billion years. It's been shining for 4.5 billion years already. A middle-aged star, stable, reliable, burning hydrogen into helium at a rate of 4 million tons per second. Every second, the Sun loses 4 million tons of mass converted into energy, radiating outward. E equals mc. Energy equals mass times the speed of light squared. A tiny amount of mass becomes an enormous amount of energy. The Sun's light warms Earth's surface to an average temperature of 15 degrees Celsius, perfect for liquid water, perfect for life. Venus is too close, 460 degrees Celsius average temperature, hot enough to melt lead. Mars is too far, minus 60 degrees Celsius average, cold enough to freeze carbon dioxide. But Earth is just right in the habitable zone, the narrow band where water stays liquid, where life can thrive. Liquid water is the key. As far as we know, all life requires water, not ice, not vapor, liquid. Water is the universal solvent. It dissolves more substances than any other liquid. Life chemistry depends on molecules moving, mixing, reacting, and that requires a liquid medium. On Earth, that medium is water. On other worlds, it might be methane or ammonia, but we haven't found those worlds yet. Earth's tilt is 23.5 degrees. This tilt creates seasons. As Earth orbits the Sun, different parts of the planet tilt toward or away from sunlight. Summer in the north means winter in the south, and vice versa. Without this tilt, there would be no seasons. The equator would be hot, the poles would be cold, but the middle latitudes would be eternal spring or autumn. No summer, no winter, no changing leaves, no snow. Would life exist without seasons? Probably, but it would be different. Seasons create rhythm. Animals migrate. Plants bloom. Seeds germinate. Life synchronizes with the tilt of the planet. Bears hibernate. Birds fly south. Trees drop their leaves. All because Earth leans slightly to one side. This tilt is stable because of the moon. Earth's moon is unusually large, 1/4 the diameter of Earth. Most moons are tiny compared to their planets, but our moon is massive, and its gravity stabilizes Earth's tilt. Without the moon, Earth's axis would wobble chaotically. The tilt could vary from 0 to 85 degrees. Climate would be unstable. Seasons would be unpredictable. Life would have a much harder time evolving. So we owe our existence to the moon, which, by the way, is slowly drifting away. Every year, the moon moves about 3.8 centimeters farther from Earth. Not much. But given enough time, billions of years, the moon will be much more distant. Tides will weaken. Days will lengthen. Eventually, Earth will become tidally locked to the moon, one side always facing it. A day will last a month, but that won't happen for billions of years. Long after humans are gone, the moon was born from a collision 4.5 billion years ago. A Mars-sized planet called Theia smashed into the young Earth. The impact vaporized both planets' surfaces. Molten rock sprayed into orbit. Over time, this debris coalesced into the moon. The moon is made of Earth's crust, a piece of our planet, torn away, now orbiting above us. Every time you see the moon, you're looking at a fragment of Earth's history. A scar, a reminder of the violence that created our world. Earth's formation was violent. For the first billion years, the planet was bombarded by asteroids and comets. The surface was molten, oceans of magma, skies filled with vaporized rock. Life couldn't exist, not yet. The planet had to cool. The bombardment, oceans had to condense from steam. Then, about 3.8 billion years ago, the late heavy bombardment ended. The solar system cleared of debris. Earth cooled. Liquid water appeared. And somehow we still don't know exactly how life began. The first cells were simple. No nucleus, no complex structures. Just membranes enclosing self-replicating molecules. But they could reproduce, they could evolve, and that was enough. Life spread rapidly. Within a few 100 million years, microbes covered the planet. They lived in hot springs, in cold oceans, in rocks deep underground. Everywhere liquid water existed, life followed. To this day, microbes are the dominant life form on Earth, not humans. Not animals, bacteria. They outnumber all other organisms combined. by mass, by diversity, by sheer adaptability. There are more bacteria in your gut than there are stars in the Milky Way. 100 trillion microbes living inside you. They help you digest food, synthesize vitamins, train your immune system. You're not an individual, you're an ecosystem, a walking, talking colony of trillions of cells, human and bacterial, cooperating to keep you alive. You share half your DNA with a banana. Sounds absurd, but it's true. All life on Earth shares a common genetic code. DNA, 4 chemical letters A, T, G, C, arranged in different orders. The same code in bacteria, in trees, in whales, in you. Evidence that we all descend from a single common ancestor. Life began once, and every living thing today is part of that original lineage. You are related to every organism on Earth, distant cousins, branches on the same vast tree of life. Earth's trees communicate underground through fungal networks called mycorrhizae. Trees share nutrients, water, and even warning signals. A forest is not a collection of individuals. It's a superorganism. When one tree is attacked by insects, it releases chemical signals through the fungal network. Neighboring trees receive the warning and begin producing defensive compounds, toxins, that make their leaves unpalatable. Trees protect each other, like neighbors looking out for neighbors. These fungal networks stretch 4 kilometers, thin white threads called hyphae, finer than human hair, weaving through the soil beneath your feet. In one pinch of forest soil, there can be several kilometers of fungal threads, invisible highways connecting every tree, every plant, every root. Scientists call it the Wood Wide Web, a biological internet older than humanity, running silently beneath the surface. The largest living organism on Earth is a fungus, not a blue whale, not a giant sequoia. A honey fungus in Oregon's Blue Mountains covers 2,385 acres. That's nearly 4 square miles. It's been growing for at least 2,400 years, maybe much longer. The fungus spreads underground, sending up mushrooms only occasionally. Most of its body is hidden, threads in the dark, digesting dead wood, connecting the forest. Fungi are neither plants nor animals. They're something else entirely. They can't photosynthesize like plants. They can't move like animals. Instead, they digest their food externally. They secrete enzymes into the environment, breaking down organic matter, then absorbing the nutrients. Fungi decompose the dead and feed the living. Without them, forests would choke on their own fallen leaves. Dead trees would pile up. The carbon cycle would halt. Carbon, the element of life. Every organic molecule contains carbon. Your body is 18% carbon by weight. The same carbon that forms diamonds deep underground. The same carbon that makes up coal, oil, graphite. Carbon is everywhere. In the air as carbon dioxide, in the ocean as dissolved carbonates, in rocks as limestone, in living things as proteins, fats, sugars, DNA. Earth's carbon cycles through different reservoirs. The atmosphere holds about 800 billion tons. The ocean holds 38,000 billion tons. But the biggest reservoir is rock. Sedimentary rocks contain more than 65 million billion tons of carbon. Most of Earth's carbon is locked away, buried, solid, safe. If it were all released into the atmosphere, Earth would become uninhabitable. A runaway greenhouse like Venus. But the cycle is balanced. Volcanoes release carbon dioxide. Plants absorb it. Animals eat plants. Animals exhale carbon dioxide. They die. Decomposers break them down. Carbon returns to the soil. Some washes into the ocean. Some forms shells. Shells sink, become limestone, get buried, get heated, melt, return to the mantle, eventually erupt from volcanoes again. The same carbon atoms have been cycling through Earth for billions of years. The carbon in your body right now might once have been in a dinosaur, or a tree, or dissolved in an ancient sea. Earth's rocks hold memory. Fossils, the preserved remains of ancient life, tell stories of vanished worlds. We've found fossils of creatures that don't resemble anything alive today. Trilobites with compound eyes, Anomalocaris with grasping appendages, Hallucigenia with spikes and stilts. Life has experimented with body plans we can barely imagine. Most failed, went extinct, became evolutionary dead ends. But some succeeded. The basic body plan of vertebrate animals with backbones has remained stable for 500 million years. Head, spine, 4 limbs, tail. Variations on this theme produced fish, amphibians, reptiles, birds, mammals. But the blueprints stayed the same because it works, because evolution conserves successful designs. 99% of all species that ever lived are now extinct. Sounds tragic, but it's natural. Species arise. They thrive for a time. Conditions change. They die out. The average species lifespan is about 1 million years. Humans, Homo sapiens, have existed for only 300,000 years. We're young, unproven. We might last another 1,000,000 years, or we might vanish in the next few thousand. 5 times in Earth's history, mass extinctions wiped out most life. The worst happened 252 million years ago. The Permian extinction killed 96% of all species. The cause, volcanic eruptions, massive ones, in Siberia. They released so much carbon dioxide that the oceans acidified. Marine life suffocated. Food chains collapsed. It took 10 million years for biodiversity to recover. But life did recover. It always does. The most recent mass extinction was 66 million years ago. An asteroid 10 kilometers wide struck what is now Mexico. The impact released energy equivalent to 10 billion atomic bombs. The sky filled with dust. Sunlight was blocked for years. Temperatures plummeted. Photosynthesis stopped. 3/4 of all species died, including all non-avian dinosaurs. But mammals survived. Small, nocturnal, adaptable. From those survivors came everything we see today. Whales, elephants, bats, primates, humans. We exist because an asteroid killed the dinosaurs. If not for that impact, mammals might still be small, shrew-like creatures hiding from reptilian predators. Extinction creates opportunity. Tragic for the dying, fortunate for the survivors. But humans are causing a 6th mass extinction. This time, it's not asteroids or volcanoes, it's us. Species are disappearing at 100 to 1,000 times the natural rate. Habitat destruction, climate change, pollution, overhunting. We're unraveling the web of life faster than evolution can. Weave new threads. Should you despair? No, because awareness is the first step toward change. Humans have also proven capable of remarkable conservation. We've brought species back from the brink. Bald eagles, humpback whales, gray wolves. When we choose to protect, we succeed. Life is resilient, but it needs time and space and our restraint. Earth's forests cover 30% of the land. That's about 4 billion hectares, but they're shrinking. Every year, we lose about 10 million hectares in area the size of Iceland. Yet forests are critical. They produce oxygen, absorb carbon dioxide, regulate rainfall, prevent erosion. A single large tree can absorb 48 pounds of carbon dioxide per year. Over its lifetime, it can sequester a ton or more. Trees also cool the planet. Through transpiration, the release of water vapor from leaves trees create clouds. Forests generate their own rain. The Amazon, for example, recycles water. Moisture evaporates from the Atlantic, falls as rain over the forest, is absorbed by trees, is released back into the air, falls again farther inland. By the time air reaches the Andes, it has rained and re-evaporated 5 or 6 times. Cut down the forest, and the rain stops. The land dries, becomes desert. But forests are recovering in some places. Abandoned farmland in the eastern United States is returning to forest. Europe's forests are expanding. China has planted billions of trees. Reforestation is possible. When humans step back, nature returns faster than you might expect. Nature is patient. After the eruption of Mount St. Helens in 1980, which destroyed 230 square miles of forest, scientists expected centuries of barren wasteland. Instead, plants returned within months, seeds blown in by wind, roots surviving underground. Within decades, the landscape was green again. Life doesn't wait for permission. It seizes every opportunity. Earth's soil is alive. 1 tablespoon of healthy soil contains more organisms than there are people on Earth. Bacteria, fungi, protozoa, nematodes, arthropods, countless microscopic creatures churning through the dirt. They break down organic matter, release nutrients, create structure. Soil is not just ground-up rock. It's a living ecosystem, and it takes centuries to form. 1 inch of topsoil can take 500 years to develop. Yet we lose topsoil 24 billion tons per year to erosion. Industrial agriculture, deforestation, overgrazing all strip the land of its living skin. Without soil, crops fail. Without crops, civilizations collapse. History is full of societies that degraded their soil and vanished. The Maya, the Mesopotamians, Easter Island. But soil can be restored. Through cover cropping, composting, reduced tillage, we can rebuild what was lost. Farmers around the world are pioneering regenerative agriculture, growing food while healing the land. It's possible to farm in a way that enriches soil instead of depleting it, to feed humanity while nurturing the earth. Earth's biodiversity is astonishing. Scientists have identified about 1.7 million species, but estimates suggest there are between 8 and 10 million species in total, maybe more. We've cataloged less than 20% of life on Earth. The rest remains undiscovered, unnamed, living quietly in forests, oceans, soils. Every year, scientists describe about 18,000 new species, insects, mostly, but also fish, plants, fungi, even mammals. In 2020, researchers discovered a new species of whale. In 2021, a new species of orangutan. How is it possible we're still finding large mammals? Because Earth is vast. Jungles are dense. Oceans are deep. There are still places humans rarely visit, corners of the world where life carries on, unbothered by our presence. The ocean alone may contain 2 million undiscovered species, most of them small, microscopic, but essential. Marine bacteria produce half the world's oxygen. Phytoplankton form the base of the oceanic food web. Without these invisible organisms, the ocean would be a dead zone. And without the ocean, Earth would be uninhabitable. The ocean is Earth's life support system. It regulates temperature, absorbs carbon dioxide, produces oxygen, distributes heat through currents. The Gulf Stream carries warm water from the tropics to northern Europe. Without it, London would have the climate of Moscow. Ocean currents are like conveyor belts, moving heat from the equator to the poles. They keep the planet habitable, balanced. But the ocean is warming. Over the past century, it has absorbed 90% of the excess heat from global warming. This has delayed atmospheric warming, but at a cost. Warmer water holds less oxygen. Coral reefs bleach. Fish migrate to cooler regions. The ocean is changing, and change is rarely easy for the creatures adapted to stability. Yet the ocean has changed before. 56 million years ago, during the Paleocene thermal maximum, global temperatures spiked by 5 to 8 degrees Celsius. The ocean acidified species went extinct, but life adapted. New species emerged. The planet recovered over a few 100,000 years, not quickly by human standards, but quickly by geological standards. Will modern life adapt to current changes? Some will, some won't. Evolution works on timescales of thousands to millions of years. We're changing the planet in decades. That's too fast for most species. But microbes, with their rapid reproduction and genetic flexibility, will adapt, as they always have. Life will persist. Just maybe not the life we know. Earth has experienced climates much warmer than today's during the Cretaceous period. 100 million years ago, there was no ice at the poles. Sea levels were 170 meters higher than now. Much of the continents were shallow seas. Forests grew in Antarctica. Dinosaurs thrived in a hothouse world. Temperatures averaged 10 degrees Celsius warmer than today. Yet life flourished. Earth has also been much colder. During the Cryogenian period, about 700 million years ago, the planet froze completely. Snowball Earth ice from pole to pole. Even the equator was frozen. How did life survive? Microbes in the ocean, beneath the ice. Volcanic activity kept some water liquid. Life persisted in tiny refuges, waiting for the thaw. And when the ice melted, triggered by volcanic carbon dioxide, life exploded back into dominance. Earth's climate is not static. It shifts. Over millennia, over millions of years, ice ages come and go. Driven by orbital variations, Earth's tilt and orbit change slightly over tens of thousands of years. These Milankovitch cycles cause ice ages, when Earth's orbit is more elliptical and the tilt is less pronounced. Less sunlight reaches the poles. Ice accumulates. Glaciers advance. The last ice age ended 11,700 years ago. For 100,000 years before that, much of North America and Europe were buried under ice sheets, kilometers thick. Sea levels were 120 meters lower than today. You could walk from France to England. Humans did. They followed migrating animals across land bridges that no longer exist. Then the ice melted. Temperatures rose. Glaciers retreated. Sea levels rose so fast, about 1 meter per century, that entire coastlines flooded within a human lifetime. Stories of great floods appear in cultures around the world. Gilgamesh, Noah, Manu. Perhaps these myths preserve memories of real events. The drowning of coastal settlements. The retreat to higher ground. Earth's ice is still melting. Greenland loses about 280 billion tons of ice per year. Antarctica loses about 150 billion tons. Together, they contribute about 1 millimeter of sea level rise annually. If all of Greenland's ice melted, sea levels would rise 7 meters. If Antarctica melted, 60 meters. But that would take centuries, maybe millennia. Ice sheets melt slowly. Water has inertia. Should you fear rising seas? Not immediately. But coastal cities should plan. Over the next century, seas may rise 1 meter, maybe more. Low-lying islands will vanish. Coastal infrastructure will flood. Millions will need to relocate. But humans are adaptable. We've survived ice ages, droughts, floods. We'll survive this too, though not without hardship. Earth's glaciers are ancient libraries. Ice cores drilled from Greenland and Antarctica preserve atmospheric samples from hundreds of thousands of years ago. Tiny air bubbles trapped in ice tell us what the atmosphere was like during past climates. Carbon dioxide levels, methane levels, temperature proxies. By reading ice, we read history. The oldest ice core comes from Antarctica. It's 800,000 years old. It shows Earth's climate oscillating between ice ages and warm periods. Regular cycles, predictable, but current carbon dioxide levels are higher than anything in that record. Not just higher, off the chart. We've pushed the atmosphere into uncharted territory. Yet Earth has seen higher carbon dioxide levels before. During the Eocene, 50 million years ago, levels were over 1,000 parts per million, 3 times today's. The planet was much warmer. No ice, forests in the Arctic, crocodiles near the poles. Life thrived in that world, just different life, different ecosystems, different distributions. The question isn't whether Earth will survive climate change. It will. The question is whether current ecosystems and current civilizations will survive. And that depends on how fast we change. Rapid change causes extinction. Slow change allows adaptation. We're changing things rapidly. That's the problem. But humans are capable of rapid change, too. We went from horse-drawn carriages to moon landings in 70 years. We invented agriculture, writing, medicine, computers. We've reshaped the planet, for better and worse. If we can destroy, we can also restore. If we can pollute, we can also clean. The choice is ours. And that's both terrifying and empowering. Earth's atmosphere is a thin shell. If Earth were the size of an apple, the atmosphere would be thinner than the skin. All the air we breathe, all the weather we experience, all the clouds and wind and rain contained in a layer barely 12 kilometers thick. Above that, air becomes too thin to breathe. By 20 kilometers, you'd need a pressure suit. By 50 kilometers, space begins. Yet this thin layer protects us from meteors, from radiation, from the cold of space. The atmosphere burns up most meteors before they reach the ground. Every day, about 100 tons of space dust and debris enter Earth's atmosphere. Most of it vaporizes, shooting stars, tiny flashes of light, fragments of comets and asteroids, incinerated by friction. Sometimes larger objects get through. In 2013, a meteor exploded over Chelyabinsk, Russia. It was about 20 meters wide and released energy equivalent to 30 Hiroshima bombs. The shockwave shattered windows, injured over 1,000 people, but no one died. The atmosphere had slowed, and fragmented the meteor before it reached the ground. The atmosphere is our shield, invisible, taken for granted, essential. Breathing is a miracle. Every breath you take contains quadrillions of molecules: nitrogen, oxygen, argon, carbon dioxide, water vapor, trace gases, molecules that have cycled through Earth's systems for eons. Some of the oxygen molecules you're inhaling right now were produced by a tree yesterday. Some were released by phytoplankton last month. You're breathing the work of countless organisms, life supporting life. Your lungs are astonishing. Unfolded, they'd cover a tennis court. 300 million alveoli, tiny air sacs where oxygen enters your bloodstream. Each breath exchanges about half a liter of air. At rest, you breathe about 12 times per minute. That's over 17,000 breaths per day. You'll take about 600 million breaths in your lifetime, each one connecting you to the planet, to the trees, to the ocean, to every living thing that produces or consumes oxygen. Earth's nitrogen cycle is equally essential. 78% of the atmosphere is nitrogen, but plants can't use atmospheric nitrogen directly. It must be fixed, converted into ammonia or nitrates. Certain bacteria do this. They live in soil, in water, in nodules, on plant roots. These bacteria take nitrogen from the air and make it available to plants. Without them, agriculture would be impossible. Life as we know it would be impossible. Humans have learned to fix nitrogen artificially. The Haber-Bosch process, invented in the early 1900s, converts atmospheric nitrogen into fertilizer. This single invention feeds half the world's population. Without synthetic fertilizer, current food production would be impossible, but it comes at a cost. Producing nitrogen fertilizer requires immense energy, and excess fertilizer runs off into rivers and oceans, causing algae blooms and dead zones. Nature's way is slower but balanced. Nitrogen-fixing bacteria, decomposers, and lightning all contribute nitrogen to the soil. Lightning alone fixes about 5 to 8 million tons of nitrogen per year. The electrical discharge splits nitrogen molecules. They react with oxygen, form nitrates, fall to earth with rain. Every thunderstorm fertilizes the land for free, powered by the sun and Earth's convection currents. Earth's phosphorus cycle is simpler, but just as vital. Phosphorus is essential for DNA, RNA, ATP molecules that store and transfer energy in cells. But phosphorus doesn't exist in the atmosphere. It's locked in rocks. Weathering releases phosphorus into soil. Plants absorb it. Animals eat plants. They die. Decomposers release the phosphorus. It returns to the soil, or it washes into the ocean, where it sinks and becomes sediment. Eventually, tectonic activity lifts that sediment back onto land. The cycle completes over millions of years. Modern agriculture mines phosphorus. We dig up phosphate rock, turn it into fertilizer, spread it on fields. But phosphate reserves are finite. Some estimates suggest we have 50 to 100 years left at current consumption rates. After that, farming becomes much harder, unless we learn to recycle phosphorus more efficiently to close the loop. Nature recycles everything. Humanity still has much to learn. Earth's deserts are not dead. They seem barren, empty, but life finds a way. In the Atacama Desert, the driest place on Earth, it hasn't rained in some areas for over 400 years. Yet microbes survive in the soil, under rocks, in salt crusts. They enter a state of suspended animation during drought. no growth, no reproduction, barely alive. Then, when rain finally comes, they wake up. Within hours, the desert blooms. Seeds that waited years suddenly germinate. Flowers carpet the sand. Desert life is patient. Some seeds can remain dormant for decades, even centuries, waiting for the perfect conditions. The oldest viable seed ever germinated was a date palm seed from Masada, Israel. It was 2,000 years old. Archaeologists found it in an ancient fortress. They planted it, and it grew. A tree from the time of Jesus, alive today. That's the power of patience, of waiting, of hope preserved in a tiny package. Cacti are masters of water conservation. Their spines are modified leaves reducing surface area, and thus water loss. Their thick stems store water. A large saguaro cactus can hold up to 200 gallons. These giants can live for 200 years, growing incredibly slowly, an inch per year in youth. They don't produce their first arm until they're 75 years old. By human standards, they're senior citizens before they even look like cacti. Desert animals are equally adapted. The kangaroo rat never drinks water. It extracts moisture from seeds. Its kidneys are so efficient, they produce urine 5 times more concentrated than human urine. The rat can survive its entire life without a single sip of water. Evolution sculpted it into a perfect desert survivor. No wasted moisture, no unnecessary heat. It's nocturnal, avoiding the scorching daytime sun, sleeping underground where temperatures are cooler. Earth's deserts are expanding. Desertification, the process by which fertile land becomes desertifies, about 12 million hectares per year. Overgrazing, deforestation, poor irrigation practices all contribute. One's greenlands turn to dust. The Sahara Desert was green 6,000 years ago. It had lakes, rivers, vegetation, rock paintings, show giraffes, hippos, crocodiles. Then the climate shifted. Rainfall patterns changed. The land dried. What was paradise became sand. But deserts can be reversed. China's Loess Plateau was once barren, eroded, lifeless. Then, starting in the 1990s, the government implemented a massive restoration project. They banned grazing, planted trees, terraced hillsides. Within 20 years, the plateau turned green. Rivers returned. Wildlife returned. 2 million people were lifted out of poverty. The land healed, and so did the communities that depended on it. Earth's grasslands cover about 40% of the land. Prairies, steppes, savannas, pampas. These are the breadbaskets of the world, where we grow wheat, corn, rice. But grasslands are disappearing faster than rainforests, converted to farms, overgrazed, fragmented by roads and cities. Wild grasslands now cover less than half their original extent, and with them, the animals that depend on them decline. The American bison once numbered 60 million. They thundered across the Great Plains in herds so large they took days to pass. By 1889, fewer than 1,000 remained. Hunted nearly to extinction, but conservation efforts brought them back. Today, about 500,000 bison roam North America, most on ranches, some in wild herds. It's not what it was, but it's better than extinction. And the bison's return has restored grasslands. Their grazing patterns promote plant diversity. They are ecosystem engineers, shapers of the land. Earth's wetlands are among the most productive ecosystems. Marshes, swamps, bogs. These waterlogged lands teem with life. They filter water, control floods, store carbon. An acre of wetland can absorb 1.5 million gallons of floodwater. Yet we've lost over half of the world's wetlands, drained for agriculture, filled for development. When wetlands disappear, floods worsen, water quality declines, fish populations crash, the land loses its kidneys. But wetlands can be restored. The Mesopotamian marshes in Iraq, once the largest wetland ecosystem in the Middle East, were drained in the 1990s. Over 90% disappeared. The marsh Arabs who lived there for thousands of years were displaced. Biodiversity collapsed. Then, after 2003, restoration began. Dams were breached. Water flowed back. Within a decade, more than half the marshes had returned. Birds came back. Fish populations rebounded. People returned to their ancestral ways of life. The land remembered. And when given the chance, it healed. Earth's mountains are islands in the sky. Each peak is an isolated ecosystem. Climb a mountain, and you pass through multiple climate zones. Tropical forest at the base, temperate forest higher up, alpine meadows, then tundra, finally, bare rock and ice. It's like traveling from the equator to the poles in a single day's hike, and the creatures at the top are isolated, cut off from similar habitats by lowlands they can't cross. Many mountain species exist nowhere else. The snow leopard, the mountain gorilla, the Andean condor. If their habitats disappear, they go extinct. There's nowhere else to go. Climate change is pushing species upslip. As temperatures warm, they follow the cold. But mountains have tops. There's only so high you can go. Animals at the summit have nowhere left to climb. Yet mountains create biodiversity. Their complex terrain slopes, valleys, cliffs, caves provides countless ecological niches. The Andes harbor more species than any other mountain range. Thousands of plants found nowhere else. Hundreds of unique birds. Mountains force air upward. Rising air cools. Water condenses. Rain falls. That's why mountains are often green, lush, life-giving. They create their own weather, their own ecosystems. Earth's highest peak is Mount Everest, 8,849 meters above sea level. But it's not Earth's tallest mountain. Measured from base to summit, Mauna Kea in Hawaii is taller 10,203 meters. Most of it is underwater, rising from the ocean floor, breaking the surface, climbing into the sky. Everest is Earth's highest point. Mauna Kea is Earth's tallest mountain. Words matter. Perspective matters. Climbing Everest requires acclimatization. At the summit, oxygen levels are 1/3 of sea level. Your body produces more red blood cells to carry what little oxygen exists. Your heart works harder. Your lungs strain. Yet people survive at the top, briefly. Without supplemental oxygen, you can last maybe 15 minutes. Then hypoxia-oxygen starvation sets in. You lose coordination. Judgment fails. Consciousness fades. The summit is called the death zone for a reason. Over 300 people have died attempting Everest. Some bodies remain on the mountain, frozen, preserved. The cold prevents decay. Climbers pass them on the way up, grim reminders of the mountain's power. Yet people still climb, drawn by challenge, by beauty, by the desire to stand on top of the world. What drives us to risk everything for a view? Perhaps the same impulse that sent our ancestors exploring new continents, the need to see what's beyond, to test ourselves against nature. But you don't need to climb Everest to find wonder. Every mountain, every hill, every rise in the land offers perspective. From height, you see patterns, rivers winding, fields quilting the valley, roads connecting towns. You see the shape of the land, how it folds and flows, how humans have adapted to it. Mountains teach humility. They were here long before us. They'll be here long after. We are brief visitors on an ancient landscape. Earth's volcanoes are windows into the planet's interior. When they erupt, they bring up material from deep below. Magma molten rock originates in the mantle, 60 to 100 kilometers down, heated by radioactive decay, by pressure, by the residual heat from Earth's formation. It rises through cracks in the crust, collects in magma chambers, and eventually erupts. There are about 1,500 active volcanoes on Earth. Active meaning they've erupted in the past 10,000 years. Most are along tectonic plate boundaries, where plates collide. One sinks beneath the other. It melts. The magma rises. Volcanoes form. The ring of fire around the Pacific Ocean contains 75% of Earth's volcanoes, a horseshoe of fire circling the world's largest ocean. Volcanic eruptions can be catastrophic. In 1815, Mount Tambora in Indonesia erupted with such force that it ejected 160 cubic kilometers of material. The eruption was heard 2,600 kilometers away. Ash blanketed the region. The following year, 1816, was called the year without a summer. Global temperatures dropped. Crops failed. Snow fell in June. Tens of thousands died from starvation, all because one mountain exploded. Yet volcanoes also create. The Hawaiian Islands are entirely volcanic. They formed over a hotspot, a plume of magma rising from deep in the mantle. As the Pacific Plate moves over this stationary hotspot, new islands form. Hawaii, the big island, is the youngest, still growing. Kilauea has been erupting almost continuously since 1983. Lava flows into the ocean, cooling, solidifying, adding new land. Creation in real time. Earth building itself. Volcanic soil is incredibly fertile. Ash contains minerals, potassium, phosphorus, calcium that plants need. That's why people live near volcanoes, despite the danger. The slopes of Mount Vesuvius are covered in farms and vineyards. The soil is rich. Crops thrive. Yes, the volcano could erupt again. It destroyed Pompeii in 79 AD, but people have short memories, and the land is generous. Underneath Yellowstone National Park lies a supervolcano. Its magma chamber is about 80 kilometers long and 40 kilometers wide. If it erupted, it would devastate much of North America. Ash would blanket the continent. Skies would darken. Temperatures would plummet. The last major eruption was 640,000 years ago. It ejected 1,000 cubic kilometers of material. Are we overdue? Maybe, maybe not. Predicting eruptions is difficult. The Earth keeps its secrets. But you shouldn't worry. The probability of a supervolcano erupting in your lifetime is incredibly small. Statistically, you're far more likely to be struck by lightning. And even if it did erupt, life would continue. Humans are adaptable. We survived the Toba supervolcano eruption 74,000 years ago, which may have reduced the human population to just a few thousand individuals. We're still here, still thriving, still wondering about our world. Earth's geysers are rare wonders. Only about 1,000 exist worldwide. Half of them are in Yellowstone. A geyser requires 3 things: heat, water, and specific plumbing. Underground chambers fill with water. Magma heats it. Pressure builds. Eventually, The superheated water flashes to steam. It erupts. Old Faithful in Yellowstone erupts about every 90 minutes. It's been doing so for as long as we've observed it. Reliable, predictable, a clockwork display of Earth's inner heat. Hot springs are more common. Water seeps underground, gets heated by magma or by descending deep where the Earth is naturally warmer, rises back to the surface. The water can be as hot as boiling or pleasantly warm. Organisms thrive in some hot springs. Thermophiles, heat-loving microbes, live in water over 100 degrees Celsius. They don't just survive, they thrive. These extremophiles teach us that life is more adaptable than we imagined. If life can exist in boiling water, where else might it exist? Mars has hot springs, perhaps, or had them. Evidence suggests ancient Mars was warmer, wetter, with volcanic activity. If so, hot springs might have existed. And if they did, life might have originated there, just as it might have originated in Earth's hot springs. Some scientists think life began in hydrothermal vents, deep-sea hot springs, where superheated water gushes from the ocean floor, rich in minerals, in energy, the perfect chemical laboratory for life's first molecules. Earth's deepest known hydrothermal vent, the water emerging from it is nearly 400 degrees Celsius, but it doesn't boil. The pressure at that depth is so high that water remains liquid even at temperatures far above its normal boiling point. And in this extreme environment, life flourishes. Giant tube worms, eyeless shrimp, bacteria that chemosynthesis using chemicals instead of sunlight for energy. These deep-sea ecosystems don't depend on the sun. Unlike almost all other life on Earth, they're powered by Earth's internal heat, by chemicals seeping from the planet's interior. If the sun went out, they'd keep living, unaware, unaffected. They remind us that life doesn't need sunlight, it just needs energy. And Earth provides energy in many forms. Earth's caves hide entire ecosystems. Mouvile Cave in Romania has been sealed off from the surface for 5.5 million years. No light, no connection to the outside world. Yet it hosts 48 species found nowhere else. How do they survive? Chemosynthesis. Bacteria in the cave convert sulfur compounds into energy. They form the base of the food web. Other organisms feed on them. A sunless ecosystem, independent, isolated, a miniature alien world beneath our feet. The world's longest cave system is Mammoth Cave in Kentucky. Over 650 kilometers of mapped passages. And there's likely more unexplored. Every year, cavers discover new tunnels, new chambers. The cave was carved by water, acidic groundwater dissolving limestone over millions of years. The rock didn't vanish. It went into solution, traveled through the water table, eventually precipitated out as stalactites and stalagmites in other chambers. Stalactites hang from the ceiling. Stalagmites rise from the floor. Remember it this way. Stalactites hold tight to the ceiling. They grow one drop at a time. Water seeps through the rock, dissolves calcium carbonate, drips from the ceiling. A tiny bit of calcium is left behind. Over centuries, a stone icicle forms. The largest known stalactite is 28 meters long. In Jada Grotto, Lebanon, it took millions of years to grow, drop by patient drop, nature's slowest sculpture. Caves are time capsules. The temperature inside stays constant year-round. No weather, no erosion. In some caves, Ice Age remains are perfectly preserved. Cave paintings in France and Spain are over 30,000 years old. Handprints, horses, bison, they looked like they were painted yesterday. Ochre and charcoal, applied by fingers and tools, by people who looked up at the same stars we see, who wondered about the same mysteries. Who were these artists? Anatomically modern humans, just like us. Same brain size, same cognitive abilities. They created art, buried their dead with care, made music from bone flutes. They were not primitive. They were us, separated by time but not by capability. If you could bring a baby from 30,000 years ago into the present, raise them in a modern society, they'd be indistinguishable from anyone else. Biology hasn't changed, only culture. Earth's human population is about 8 billion. We crossed 7 billion in 2011, 8 billion in 2022. For most of human history, the population was tiny. 10,000 years ago, fewer than 5 million people existed. Then agriculture allowed populations to grow. Villages became cities. Cities became civilizations. But growth was slow. It took until 1804 to reach 1 billion, then just 123 years to reach 2 billion. Then doubling accelerated. Now, growth is slowing. Birth rates are declining in most countries. The global population is expected to peak around 10 billion in the 2080s. Then it may decline. We're approaching a demographic transition. From high birth and death rates to low birth and death rates. This happened in Europe. It's happening in Asia. It will happen in Africa. As education improves, as women gain autonomy, as child mortality drops, families choose fewer children. Is this good or bad? Neither. It just is. A smaller population might ease pressure on resources, less demand for food, water, energy. But it also means aging societies, fewer workers, more retirees, economic challenges. Every shift creates new problems and new solutions. Humanity will adapt. We always do. Earth can support 8 billion people. We produce enough food, enough energy. The problem isn't capacity, it's distribution. Some regions have excess, others face scarcity. We waste about 1/3 of all food produced, enough to feed 2 billion people. If we reduced waste, shared more equitably, farmed more sustainably, Earth could comfortably support current populations. The challenge is political, not physical. Cities are humanity's most efficient creation, dense, centralized, sharing infrastructure. People in cities use fewer resources per capita than people in rural areas. They drive less, share walls, use public transport. As the world urbanizes, it becomes easier to provide clean water, sanitation, electricity, internet to more people. Cities are not the enemy of nature. Well-designed cities can be the solution. Singapore is a model, a city-state with no natural resources. They import water, food, energy, yet they've built one of the world's greenest cities, vertical gardens, rooftop parks, trees lining every street. Over 50% of the city is green space. They've proven that density and nature can coexist. You don't need sprawl to have beauty. Earth's coral reefs are underwater cities, built not by humans, but by tiny polyp soft-bodied animals related to jellyfish. Each polyp secretes calcium carbonate, forming a hard skeleton. Millions of polyps, millions of skeletons. Over centuries, they build reefs. The Great Barrier Reef is the largest living structure on Earth, visible from space. Over 2,300 kilometers long, composed of nearly 3,000 individual reefs. Coral reefs cover less than 1% of the ocean floor, yet they support 25% of marine species. More than 1 million species live in and around reefs: fish, mollusks, crustaceans, sponges. Reefs are the rainforests of the sea, biodiversity hotspots, nurseries for fish, barriers that protect coastlines from storms. But reefs are dying. Rising ocean temperatures cause coral bleaching. Corals have a symbiotic relationship with algae. The algae photosynthesize, provide food. In return, the coral provides shelter. When water warms, the algae produce toxins. The coral expels them, loses its color, loses its food source. If conditions don't improve, the coral dies. Over half the world's reefs have bleached in recent decades. Some have recovered. Many haven't. Yet hope remains. Some corals are heat-resistant. Scientists are breeding these resilient strains, planting them in damaged reefs. It's not a perfect solution, but it buys time. Time for emissions to drop, for oceans to stabilize. Nature is resilient, but it needs our help, or at least our restraint. Earth's oceans contain 38,000 billion tons of carbon, 50 times more than the atmosphere. The ocean absorbs about 1/4 of human carbon emissions. Without this absorption, atmospheric carbon dioxide would be much higher, warming much faster. The ocean is doing us a favor, but it's not free. Absorbed carbon acidifies the water, makes it harder for shellfish and corals to build their calcium carbonate structures. The ocean is becoming more acidic than it's been in millions of years. But the ocean is vast, slow to change, slow to heal. Even if we stopped all emissions today, it would take centuries for the ocean to return to pre-industrial chemistry. The ocean has inertia, momentum. What we do now will affect the ocean for generations. Our great-great-grandchildren will inherit the ocean we're creating today. That's both sobering and empowering. Sobering because the damage is lasting. Empowering because our actions matter. Every choice cascades into the future. And while we can't undo the past, we can shape what comes next. That's what it means to be human, to live in time, to affect the future, to leave a legacy for better or worse. Earth's rivers are the planet's bloodstream, carrying water, nutrients, sediment, connecting mountains to oceans. The longest river is the Nile, 6,650 kilometers. It flows north through 11 countries, from the highlands of Africa to the Mediterranean. For thousands of years, it sustained Egyptian civilization. The river flooded annually, deposited nutrient-rich silt on farmland. Crops flourished. Empires rose. But the Amazon carries more water. 20% of all river water on Earth. Every second, it discharges 209,000 cubic meters into the Atlantic Ocean. That's enough to fill an Olympic swimming pool in less than 2 seconds. The river is so wide in places, you can't see the opposite bank. During flood season, it spreads over 100 kilometers wide. Forest becomes waterscape. Fish swim through treetops. The Amazon basin contains 1/5 of the world's fresh water and 1/10 of all species. More than 3,000 species of fish live in the Amazon, more than in the entire Atlantic Ocean. Why such diversity, complexity? The river has countless tributaries, oxbow lakes, flooded forests. Each microhabitat hosts unique communities. Separation creates speciation. Geographic barriers split populations. Over time, they diverge, become new species. Rivers shape the land. They carve valleys, build deltas. The Mississippi River Delta grows about 3 square kilometers per year. Sediment washed from the interior of North America, carried downstream, deposited at the river's mouth. New land forming from old mountains, erosion and deposition, the eternal cycle. In a million years, the delta will look completely different. Rivers are sculptors working on geological timescales. But humans have changed rivers. We've dammed most major rivers. There are over 58,000 large dams worldwide. They provide hydropower, store water, control floods, but they also fragment rivers, block fish migration, trap sediment. The Colorado River no longer reaches the ocean, drained by agriculture, by cities, by dams. The river that carved the Grand Canyon now dies in the desert. Yet, rivers can recover. When dams are removed, life returns. The Elwha River in Washington state had 2 dams for a century. Salmon populations collapsed. Then, in 2012, the dams were demolished. Within months, salmon returned. Vegetation regrew. Within a decade, the river had healed, not completely, but significantly. Rivers remember their courses. When we stop blocking them, they remember how to flow. Earth's lakes are temporary. On geological timescales, all lakes are young. Most formed within the last 20,000 years. After the Ice Age, glaciers retreated, carved basins, meltwater filled them. Eventually, sediment fills lakes in. Rivers carry silt. It settles. The lake becomes a marsh, then a meadow, then forest. Lakes are transitional, a pause between mountain and ocean. But some lakes are ancient. Lake Baikal in Siberia is 25 million years old, the oldest lake on Earth, and the deepest 1,642 meters. It contains 23% of the world's fresh surface water, more than all the Great Lakes combined. Its water is so clear you can see 40 meters down, and it's home to 1,700 species, 2/3 of them found nowhere else. A world within a world, isolated, evolving independently. The Great Lakes of North America are much younger, about 14,000 years old, formed by glacial meltwater. Together, they contain 21% of the world's fresh surface water. Superior, Michigan, Huron, Erie, Ontario. They're like inland seas, so large they create their own weather. Lake effect, snowberries, cities on their shores. Cold air crosses warm water, picks up moisture, dumps it as snow. Buffalo, Cleveland. They endure because of the lakes. Lakes can disappear. The Oral Sea, once the 4th largest lake in the world, has shrunk to 10% of its former size. Soviet irrigation projects diverted the rivers that fed it. Water levels dropped, salinity increased, fish died. Fishing villages became ghost towns. Dust storms now carry salt and pesticides from the exposed lakebed, a man-made disaster, a warning about misusing water. But efforts to restore the North Aral Sea have succeeded. A damn better water management. Water returned, fish returned. It's not what it was, but it's alive again. When we admit mistakes and act, recovery is possible. Nature wants to heal. We just have to let it. Earth's groundwater is invisible, but vital. Aquifers, underground layers of rock that hold water, supply 30% of the world's fresh water. Some are shallow, recharged by rain within years. Others are fossil aquifers filled during wetter climates thousands of years ago. Once drained, they don't refill, at least not on human timescales. The Ogallala Aquifer, beneath the Great Plains, supplies 1/3 of U.S. irrigation water. But it's being depleted faster than it reaches. In some areas, the water table has dropped 40 meters. Wells run dry. Farms struggle. Sustainable water use is not optional, it's survival. Humans can live weeks without food, but only days without water. Civilization needs reliable water. Every great city in history arose near water. Rivers, lakes, springs, aquifers. When the water failed, the cities fell. Mesopotamia, the Indus Valley, the Maya lowlands. Water is the foundation of everything. Humans are 70% water by weight, but 99% by molecule count. Every biological process requires water: digestion, circulation, temperature, regulation, waste removal. You lose about 2 liters of water per day. Through breath, sweat, urine. You must replace it. Drink, eat water-rich foods. Dehydration affects cognition, mood, energy, physical performance. Even mild dehydration, 2% of body weight, impairs function. The water you drink today has been on Earth for billions of years, cycling, evaporating, condensing, flowing. Dinosaurs drank it. Ancient humans drank it. Now you drink it. Someday, someone will drink the water currently in your body. We don't own water. We borrow it for a moment, then return it to the cycle. Earth's clouds are sculptures of water vapor, formed when humid air rises, cools, condenses around tiny particles, dust, salt, pollen. Each cloud droplet is about 20 microns wide, thinner than a human hair. Millions of droplets form a cloud. Collectively, they reflect sunlight, keep Earth cool. Without clouds, the planet would be significantly hotter. Clouds are Earth's thermostat. Clouds come in types: cumulus fluffy, fair weather clouds, stratus flat, gray, overcast, cirrus wispy, high altitude ice crystals, cumulone imbestowering thunderstorm giants. The tallest thunderstorms reach 18 kilometers high. From near the surface to the stratosphere, inside, updrafts of over 100 kilometers per hour carry moisture upward. It freezes, falls, gets lifted again. Layers of ice build. Eventually, hail forms. Some stones the size of baseballs, falling at terminal velocity, over 150 kilometers per hour, deadly. Yet, most clouds are gentle, drifting, shifting, dissolving, and reforming. The average cloud weighs about 500,000 kilograms, as much as 100 elephants. How does it stay aloft? The droplets are tiny. Air resistance, updrafts. They fall so slowly, about 1 centimeter per second, that even weak updrafts keep them suspended. When droplets merge into larger drops, they fall faster, overcome updrafts, become rain. Rain is a miracle you've forgotten. The smell of rain on dry soil petrichor. That scent is geosmin, a compound released by soil bacteria. Humans can detect it at 5 parts per trillion. We evolved to recognize it, to know water is near. Survival depended on finding water, so your brain rewards you. That smell brings peace, memory, a sense of home. Every raindrop falls at the same speed, about 9 meters per second. Terminal velocity, the speed where gravity and air resistance balance. Small drops fall slower, large drops faster. But there's a maximum size. If a raindrop grows larger than 5 millimeters, air resistance tears it apart. It splits into smaller drops. Raindrops aren't teardrop-shaped. They're spherical or slightly flattened. Physics shapes them. Surface tension, air pressure. The wettest place on Earth is Mawsynram, India. It receives about 11,872 millimeters of rain per year. That's almost 12 meters. During monsoon season, it rains nearly every day. Streets become rivers. Houses are built on stilts. Yet people live there, adapt, thrive. Humans can make a home anywhere. Deserts, tundras, high mountains. We are the ultimate generalists. The driest place is the Atacama Desert. Some areas haven't seen rain in over 400 years. Yet morning fog provides moisture. Fog-catching nets collect water. Lichen and cacti absorb it. Life finds moisture even in the driest places. Adaptation is life's superpower. Earth's weather is powered by the sun. Sunlight heats the surface unevenly. Equator more than poles. Land more than ocean. This creates temperature differences. Hot air rises. Cold air sinks. Convection currents form. Air flows from high pressure to low pressure. We call this wind. The atmosphere constantly trying to balance itself, to equalize temperature. But the sun keeps heating unevenly, so the wind never stops. The fastest wind speed recorded on Earth's surface is 408 kilometers per hour. During Tropical Cyclone Olivia in Australia, 1996, but higher in the atmosphere, jet streams reach 400 kilometers per hour regularly. These rivers of air flow west to east, driven by the temperature difference between polar and tropical air. Airplanes use them. Flying east, tailwinds shorten flights. Flying west, headwinds lengthen them. The same trip can differ by hours, depending on the wind. Wind shapes the planet. It carries seeds, pollen, dust. Every year, 180 million tons of dust blow from the Sahara across the Atlantic to the Amazon. Phosphorus in that dust fertilizes the rainforest. Without African dust, the Amazon would be less productive. Continents connected by wind. Ecosystems linked across oceans. Everything is connected. A butterfly flaps in Africa. The Amazon blooms. But that's not chaos theory. That's the real, physical transfer of nutrients. The Sahara feeds the Amazon, giving back to the land it once resembled. 6,000 years ago, the Sahara was green. The Amazon was drier. Climates shift. Deserts become forests. Forests become deserts. On timescales of millennia, what seems permanent is temporary. What seems dead may bloom again. Earth's seasons are predictable. In temperate zones, at least, spring, summer, autumn, winter. Each brings changes. Temperatures shift. Daylight lengthens or shortens. Plants respond. Animals respond. Migration is one response. Birds fly thousands of kilometers, following summer, chasing food. The Arctic tern holds the migration record. It flies from the Arctic to the Antarctic and back. About 70,000 kilometers per year. It experiences 2 summers, never seeing winter. Over its 30-year lifespan, it travels 2.4 million kilometers, the equivalent of 3 round trips to the moon. A bird weighing 100 grams, fragile-looking, yet capable of crossing the planet year after year. Migration is instinct, encoded in genes. Birds navigate by the sun, by stars, by Earth's magnetic field. Some have magnetite crystals in their beaks, tiny compass needles. They can sense magnetic fields, know which way is north, which way is home. Humans lost this sense, if we ever had it. We rely on tools, maps, GPS, but birds carry navigation internally, a biological marvel. Monarch butterflies also migrate, from Canada to Mexico, up to 4,800 kilometers. A journey that takes multiple generations. No single butterfly completes the round trip. They're born in the north, fly south, lay eggs, die. Their offspring fly north, lay eggs, die. Yet, somehow, the great-great-grandchildren return to the same trees in Mexico, trees they've never seen. How do they know? We don't fully understand. Genetic memory, perhaps? Magnetic sensing, sun compass. Nature keeps secrets. Earth's magnetic field is a shield, deflecting charged particles from the sun, the solar wind. Without it, the solar wind would strip away our atmosphere, like it did on Mars. Mars once had a magnetic field. Then the core cooled. The field collapsed. Solar wind eroded the atmosphere. Water evaporated. Mars died. Not all at once, slowly, over millions of years, but it died. Earth's core is still hot and will remain so for billions of years. We're safe. Our magnetic field protects us, not just from solar wind, but from cosmic rays, high-energy particles, from exploding stars across the galaxy. Space is not empty. It's filled with radiation, deadly to unprotected life. But Earth's magnetic field and atmosphere absorb most of it. We walk under an invisible shield, never noticing, never thanking the molten iron churning beneath our feet. Auroras are visible proof of this shield. When solar wind particles enter Earth's magnetic field near the poles, they collide with atmospheric gases. Oxygen glows green and red. Nitrogen glows blue and purple. The Aurora Borealis Northern Lights. Aurora, Australia's Southern Lights. Dancing curtains of color, shifting, shimmering, ethereal. People travel thousands of kilometers to see them, stand in freezing darkness, watching the sky come alive. Auroras occur on other planets too. Jupiter has auroras, Saturn, Uranus, Neptune, even some moons, Ganymede, Io. Wherever there's a magnetic field and an atmosphere, auroras can form. They're universal, a reminder that the physics governing Earth governs the cosmos. We're not separate from space. We're part of it, a planet among planets, governed by the same laws. Earth's gravity holds everything down. At the surface, gravity accelerates objects at 9.8 meters per second squared. Drop something. It falls. Predictable, reliable. Yet gravity is the weakest of the four fundamental forces. Electromagnetism is a trillion times stronger. The strong nuclear force is even stronger. Yet gravity shapes the universe because it acts on everything and it adds up. Enough mass and gravity becomes dominant. It forms stars, planets, galaxies, black holes. But what is gravity? Newton said. It's a force. Einstein said, it's the curvature of space-time. Mass bends space. Objects follow the curves. Earth orbits the sun, not because of a force pulling it, but because the sun's math warps space-time. Earth follows the straightest path through curved space. It's not intuitive, but it's accurate, proven by countless experiments. Gravity also affects time. The stronger the gravity, the slower time moves. At sea level, time runs slightly slower than on a mountaintop. The difference is tiny, billionths of a second per day. But GPS satellites have to account for it. They orbit high above Earth, where gravity is weaker. Time runs faster for them. If engineers didn't correct for this, GPS would drift by kilometers per day. Relativity isn't just theory. It's engineering. You are aging faster when you stand than when you lie down, because your head is farther from Earth's center. Gravity is slightly weaker. Time runs slightly faster. The difference is infinitesimal, about 90 nanoseconds per day, but it's real, measurable. Atomic clocks can detect it. Time is not absolute. It depends on where you are, how fast you're moving. Einstein shattered our intuitions, and the universe became stranger, more beautiful. Earth's rotation creates the Coriolis effect. As the planet spins, objects moving north or south are deflected. In the northern hemisphere, deflected right. In the southern hemisphere, deflected left. This affects winds, ocean currents, even artillery shells. Long-range artillery must account for Earth's rotation. Fire east, and the shell lands slightly north in the northern hemisphere. Fire west, and it lands slightly south. The planet spins beneath the shell while it's in the air, changing the impact point. Hurricanes spin because of the Coriolis effect, counterclockwise in the north, clockwise in the south, but not at the equator. There, the Coriolis effect is zero. Hurricanes can't form within about 5 degrees of the equator. The spinning motion doesn't develop. That's why tropical rainforests near the equator don't experience hurricanes. Geography and physics protect them. A hurricane is an engine powered by warm ocean water. Water evaporates, rises, condenses into clouds, releases heat. That heat warms the air. It rises faster, draws in more moist air. Positive feedback. The storm grows. At its peak, a large hurricane releases energy equivalent to a 10-megaton nuclear bomb every 20 minutes. Nature's power dwarfs humanity's. Always has, always will. Yet humans can survive hurricanes with preparation, strong buildings, early warning, evacuation. We've learned to live with nature's violence, not control it, but anticipate it. Weather prediction has improved dramatically. Satellites, computer models, we can see storms forming, track their paths, warn people days in advance. Thousands of lives saved every year by knowledge, by technology, by cooperation. Earth's atmosphere has layers. Troposphere where weather happens. Stratosphere where ozone protects us. Mesosphere where meteors burn. Thermosphere where auroras glow. Exosphere where atmosphere fades into space. Each layer has distinct properties. Temperature, pressure, composition. The boundaries between layers are not sharp. They blend, transition. Nature doesn't do hard edges. Humans are 70% water by weight, but 99% by molecule count. Every biological process requires water, digestion, circulation, temperature, regulation, waste removal. You lose about 2 liters of water per day. Through breath, sweat, urine. You must replace it. Drink, eat water-rich foods. Dehydration affects cognition, mood, energy, physical performance. Even mild dehydration, 2% of body weight, pairs function. The water you drink today has been on Earth for billions of years, cycling, evaporating, condensing, flowing. Dinosaurs drank it. Ancient humans drank it. Now you drink it. Someday, someone will drink the water currently in your body. We don't own water. We borrow it for a moment, then return it to the cycle. Earth's clouds are sculptures of water vapor, formed when humid air rises, cools, condenses around tiny particles, dust, salt, pollen. Each cloud droplet is about 20 microns wide, thinner than a human hair. Millions of droplets form a cloud. Collectively, they reflect sunlight, keep Earth cool. Without clouds, the planet would be significantly hotter. Clouds are Earth's thermostat. Clouds come in types. Cumulus fluffy, fair weather clouds, stratus flat, gray, overcast, cirrus wispy, high altitude ice crystals, cumulone imbestowering thunderstorm giants. The tallest thunderstorms reach 18 kilometers high. From near the surface to the stratosphere, inside, updrafts of over 100 kilometers per hour carry moisture upward. It freezes, falls, gets lifted again. Layers of ice build. Eventually, hail forms. Some stones the size of baseballs, falling at terminal velocity, over 150 kilometers per hour, deadly. Yet, most clouds are gentle, drifting, shifting, dissolving, and reforming. The average cloud weighs about 500,000 kilograms, as much as 100 elephants. How does it stay aloft? The droplets are tiny, air resistance, updrafts. They fall so slowly, about 1 centimeter per second, that even weak updrafts keep them suspended. When droplets merge into larger drops, they fall faster, overcome updrafts, become rain. Rain is a miracle you've forgotten. The smell of rain on dry soil petrichor. That scent is geosmin, a compound released by soil bacteria. Humans can detect it at 5 parts per trillion. We evolved to recognize it, to know water is near. Survival depended on finding water, so your brain rewards you. That smell brings peace, memory, a sense of home. Every raindrop falls at the same speed, about 9 meters per second. Terminal velocity, the speed where gravity and air resistance balance. Small drops fall slower, large drops faster. But there's a maximum size. If a raindrop grows larger than 5 millimeters, air resistance tears it apart. It splits into smaller drops. Raindrops aren't teardrop-shaped. They're spherical or slightly flattened. Physics shapes them. Surface tension, air pressure. The wettest place on Earth is Mawsynram, India. It receives about 11,872 millimeters of rain per year. That's almost 12 meters. During monsoon season, it rains nearly every day. Streets become rivers. Houses are built on stilts. Yet people live there, adapt, thrive. Humans can make a home anywhere. Deserts, tundras, high mountains. We are the ultimate generalists. The driest place is the Atacama Desert. Some areas haven't seen rain in over 400 years. Yet morning fog provides moisture. Fog-catching nets collect water. Lichen and cacti absorb it. Life finds moisture even in the driest places. Adaptation is life's superpower. Earth's weather is powered by the sun. Sunlight heats the surface unevenly. Equator more than poles. Land more than ocean. This creates temperature differences. Hot air rises. Cold air sinks. Convection currents form. Air flows from high pressure to low pressure. We call this wind. The atmosphere constantly trying to balance itself, to equalize temperature. But the sun keeps heating unevenly, so the wind never stops. The fastest wind speed recorded on Earth's surface is 408 kilometers per hour. During Tropical Cyclone Olivia in Australia, 1,996, but higher in the atmosphere, jet streams reach 400 kilometers per hour regularly. These rivers of air flow west to east, driven by the temperature difference between polar and tropical air. Airplanes use them. Flying east, tailwinds shorten flights. Flying west, headwinds lengthen them. The same trip can differ by hours, depending on the wind. Wind shapes the planet. It carries seeds, pollen, dust. Every year, 180 million tons of dust blow from the Sahara across the Atlantic to the Amazon. Phosphorus in that dust fertilizes the rainforest. Without African dust, the Amazon would be less productive. Continents connected by wind. Ecosystems linked across oceans. Everything is connected. A butterfly flaps in Africa. The Amazon blooms. But that's not chaos theory. That's the real, physical transfer of nutrients. The Sahara feeds the Amazon, giving back to the land it once resembled. 6,000 years ago, the Sahara was green. The Amazon was drier. Climates shift. Deserts become forests. Forests become deserts. On timescales of millennia, what seems permanent is temporary. What seems dead may bloom again. Earth's seasons are predictable. In temperate zones, at least, spring, summer, autumn, winter. Each brings changes. Temperatures shift. Daylight lengthens or shortens. Plants respond. Animals respond. Migration is one response. Birds fly thousands of kilometers, following summer, chasing food. The Arctic tern holds the migration record. It flies from the Arctic to the Antarctic and back. About 70,000 kilometers per year. It experiences 2 summers, never seeing winter. Over its 30-year lifespan, it travels 2.4 million kilometers, the equivalent of 3 round trips to the moon. A bird weighing 100 grams, fragile-looking, yet capable of crossing the planet year after year. Migration is instinct, encoded in genes. Birds navigate by the sun, by stars, by Earth's magnetic field. Some have magnetite crystals in their beaks, tiny compass needles. They can sense magnetic fields, know which way is north, which way is home. Humans lost this sense, if we ever had it. We rely on tools, maps, GPS, but birds carry navigation internally, a biological marvel. Monarch butterflies also migrate from Canada to Mexico, up to 4,800 kilometers, a journey that takes multiple generations. No single butterfly completes the round trip. They're born in the north, fly south, lay eggs, die. Their offspring fly north, lay eggs, die. Yet, somehow, the great-great-grandchildren return to the same trees in Mexico, trees they've never seen. How do they know? We don't fully understand. Genetic memory, perhaps? Magnetic sensing, sun compass. Nature keeps secrets. Earth's magnetic field is a shield, deflecting charged particles from the sun, the solar wind. Without it, the solar wind would strip away our atmosphere, like it did on Mars. Mars once had a magnetic field. Then the core cooled. The field collapsed. Solar wind eroded the atmosphere. Water evaporated. Mars died. Not all at once, slowly, over millions of years, but it died. Earth's core is still hot and will remain so for billions of years. We're safe. Our magnetic field protects us, not just from solar wind, but from cosmic rays, high-energy particles, from exploding stars across the galaxy. Space is not empty. It's filled with radiation, deadly to unprotected life. But Earth's magnetic field and atmosphere absorb most of it. We walk under an invisible shield, never noticing, never thanking the molten iron churning beneath our feet. Auroras are visible proof of this shield. When solar wind particles enter Earth's magnetic field near the poles, they collide with atmospheric gases. Oxygen glows green and red. Nitrogen glows blue and purple. The Aurora Borealis Northern Lights. Aurora Australia's Southern Lights. Dancing curtains of color, shifting, shimmering, ethereal. People travel thousands of kilometers to see them, stand in freezing darkness, watching the sky come alive. Auroras occur on other planets too. Jupiter has auroras, Saturn, Uranus, Neptune, even some moons, Ganymede, Io. Wherever there's a magnetic field and an atmosphere, auroras can form. They're universal, a reminder that the physics governing Earth governs the cosmos. We're not separate from space. We're part of it, a planet among planets, governed by the same laws. Earth's gravity holds everything down. At the surface, gravity accelerates objects at 9.8 meters per second squared. Drop something, it falls, predictable, reliable. Yet gravity is the weakest of the four fundamental forces. Electromagnetism is a trillion times stronger. The strong nuclear force is even stronger. Yet gravity shapes the universe because it acts on everything and it adds up. Enough mass and gravity becomes dominant. It forms stars, planets, galaxies, black holes. But what is gravity? Newton said, it's a force. Einstein said, it's the curvature of space-time. Mass bends space. Objects follow the curves. Earth orbits the sun, not because of a force pulling it, but because the sun's math warps space-time. Earth follows the straightest path through curved space. It's not intuitive, but it's accurate, proven by countless experiments. Gravity also affects time. The stronger the gravity, the slower time moves. At sea level, time runs slightly slower than on a mountaintop. The difference is tiny, billionths of a second per day. But GPS satellites have to account for it. They orbit high above Earth, where gravity is weaker. Time runs faster for them. If engineers didn't correct for this, GPS would drift by kilometers per day. Relativity isn't just theory. It's engineering. You are aging faster when you stand than when you lie down, because your head is farther from Earth's center. Gravity is slightly weaker. Time runs slightly faster. The difference is infinitesimal, about 90 nanoseconds per day, but it's real, measurable. Atomic clocks can detect it. Time is not absolute. It depends on where you are, how fast you're moving. Einstein shattered our intuitions, and the universe became stranger, more beautiful. Earth's rotation creates the Coriolis effect. As the planet spins, objects moving north or south are deflected. In the northern hemisphere, deflected right. In the southern hemisphere, deflected left. This affects winds, ocean currents, even artillery shells. Long-range artillery must account for Earth's rotation. Fire east, and the shell lands slightly north in the northern hemisphere. Fire west, and it lands slightly south. The planet spins beneath the shell while it's in the air, changing the impact point. Hurricanes spin because of the Coriolis effect, counterclockwise in the north, clockwise in the south, but not at the equator. There, the Coriolis effect is zero. Hurricanes can't form within about 5 degrees of the equator. The spinning motion doesn't develop. That's why tropical rainforests near the equator don't experience hurricanes. Geography and physics protect them. A hurricane is an engine powered by warm ocean water. Water evaporates, rises, condenses into clouds, releases heat. That heat warms the air. It rises faster, draws in more moist air. Positive feedback. The storm grows. At its peak, a large hurricane releases energy equivalent to a 10 megaton nuclear bomb every 20 minutes. Nature's power dwarfs humanity's. Always has, always will. Yet humans can survive hurricanes with preparation, strong buildings, early warning, evacuation. We've learned to live with nature's violence, not control it, but anticipate it. Weather prediction has improved dramatically. Satellites, computer models, we can see storms forming, track their paths, warn people days in advance. Thousands of lives saved every year by knowledge, by technology, by cooperation. Earth's atmosphere has layers. Troposphere where weather happens. Stratosphere where ozone protects us. Mesosphere where meteors burn. Thermosphere where auroras glow. Exosphere where atmosphere fades into space. Each layer has distinct properties. Temperature, pressure, composition. The boundaries between layers are not sharp. They blend, transition. Nature doesn't do hard edges. The ozone layer is healing. In the 1980s, scientists discovered a hole over Antarctica caused by chlorofluorocarbons, CFCs, used in refrigerators and aerosol cans. These chemicals broke down ozone. Without ozone, ultraviolet radiation from the sun reached the surface. Skin cancer rates would have skyrocketed. But the world acted. The Montreal Protocol. Nations agreed to phase out CFCs, and it worked. The ozone hole is shrinking. Expected to fully recover by 2070. Proof that global cooperation can solve environmental problems. Earth's atmosphere is thicker at the equator because the planet bulges there. Centrifugal force from rotation. The equator is 21 kilometers farther from Earth's center than the poles. So Mount Chimborazo in Ecuador, though not the tallest mountain by elevation, is the farthest point from Earth's center. Its summit is 6,384 kilometers from the center. Everest is only 6,382 kilometers. Perspective matters. Definitions matter. Earth is not a perfect sphere. It's an oblate spheroid, squashed at the poles, bulging at the equator. The diameter through the equator is 43 kilometers greater than the diameter through the poles. You weigh slightly less at the equator because you're farther from Earth's center. Gravity is weaker, but you don't notice. The difference is less than 1%. Earth's shape changes slowly. Ice sheets press down on continents. When they melt, the land rebounds. Scandinavia is rising, about 1 centimeter per year. The weight of Ice Age glaciers compressed the crust. Now it's bouncing back. In 10,000 years, the Baltic Sea might drain. Land rising, water flowing out. The planet is elastic, not rigid. It bends. It remembers. The moon raises tides, not just in the ocean, but in the land. Earth's crust rises and falls about 30 centimeters twice per day. You don't feel it. Everything moves together. But sensitive instruments detect it. The planet breathes with the moon's gravity, expanding, contracting, a slow pulse, invisible but real. Tides are highest during full and new moons, when the sun, moon, and earth align. Spring tides, nothing to do with the season. The sun's gravity and moon's gravity add together. Tides are lowest during quarter moons. When sun and moon are at right angles, neaptides, gravitational forces partially cancel. The dance of celestial bodies affects even the shore you walk on. The highest tides on Earth occur in the Bay of Fundy, Canada, up to 16 meters between high and low tide. Twice a day, 160 billion tons of water flow in and out, more than all the world's rivers combined. The bay's shape funnels the tide, amplifies it, creates a tidal bora wave that travels upstream in rivers. People surf the tidal bore, riding a wave created by the moon. Earth's beaches are temporary. Sand moves, currents shift it, waves redistribute it. A beach today may be gone tomorrow, eroded by storms, deposited elsewhere. Sand grains are fragments of mountains, worn down, carried by rivers, deposited at the coast. Each grain has traveled hundreds of kilometers, over thousands of years, from highlands to lowlands, from solid rock to tiny particle. Beaches are not just sand. Some are pebbles. Some are shells. Some are volcanic black sand. Hawaii has green sand beaches, made from olivine crystals, a mineral from the mantle, brought up by volcanoes. The Bahamas have pink sand beaches, crushed coral and shells mixed with white sand. Every beach tells a story of geology, of life, of time. Coastal erosion is natural. Cliffs crumble, shorelines retreat. The white cliffs of Dover lose about 1 centimeter per year. Chalk dissolved by rain, undermined by waves. In a million years, they'll be gone, but new cliffs will form elsewhere. Earth constantly reshapes its edges. The interface between land and sea is always moving, always negotiating. Yet, humans try to hold the line. Seawalls, groins, beach nourishment. We pump sand from offshore, dump it on eroding beaches. It washes away. We pump more, fighting a losing battle, because the ocean is stronger, more patient. Eventually, we'll have to retreat, build farther inland. Let the coast be dynamic. Nature doesn't respect property lines. Earth's islands are diverse, some volcanic, some coral, some continental fragments. Madagascar broke from Africa. New Zealand broke from Australia. They drifted away, taking their ecosystems with them. Isolation creates uniqueness. Species evolve independently. Madagascar has lemurs found nowhere else. New Zealand had moage, giant flightless birds, hunted to extinction by humans, but for millions of years they thrived, unbothered by predators. Islands are laboratories of evolution. Small, isolated species arrive by chance, blown by wind, carried by birds, floating on debris. Then they adapt to the island's specific conditions. The Galapagos finches. Each island has different beak shapes, suited to different foods. Darwin saw this, understood the implication. Species aren't fixed. They change, adapt, evolve. Evolution is not just history. It's happening now. In cities, pigeons are evolving shorter wings, better for quick takeoffs in urban environments. Peppered moths in England changed color during the Industrial Revolution. Dark moths were camouflaged against soot-covered trees. When pollution controls cleaned the air, light-colored moths returned. Evolution in real time, responding to human changes. Humans are still evolving. Slowly, lactose tolerance evolved in pastoral societies. Adults who could digest milk had a nutritional advantage. Sickle cell trait persists in regions with malaria. 1 copy of the gene provides protection. 2 copies cause disease. Evolution is a balance. Trade-offs, compromises. No perfect solution, just good enough to survive and reproduce. Earth's biodiversity is not evenly distributed. Tropical regions have more species. The tropics cover 40% of the planet, but host 90% of species. Why? Warmth, sunlight, rainfall, energy drives diversity. More energy means more photosynthesis, more plants, more herbivores, more predators, complex food webs, countless niches. Evolution has had more time to work in the tropics. Ice ages didn't erase life there. Continuity allowed complexity, but diversity is everywhere, even deserts, even tundras. The Arctic has fewer species, but unique ones. Polar bears, Arctic foxes, snowy owls, each adapted to extreme cold. Thick fur, small ears, countercurrent heat exchange in blood vessels. Survival at 60 degrees below zero. Life finds a way, always. Earth's oldest living individual is a tree, a Great Basin bristlecone pine in California, over 5,000 years old. It was a seedling when the pyramids were built. It's still alive, still growing, though slowly. 1 ring per year. Each ring records climate, wet years, dry years, cold years. The tree is a living archive, 5 millennia of weather, encoded in wood. But the oldest living organism is not a tree. It's Pandoa clonal colony of quaking aspen in Utah. It looks like a forest. 47,000 individual stems, but they're all connected underground. 1 root system, genetically identical. Pando weighs 6,000 tons, and it's been alive for 80,000 years, maybe longer. It survived ice ages, megafauna, climate shifts. It's still here, quietly growing in the mountains. Age is perspective. Humans live 70 to 80 years. Trees live hundreds or thousands. Bristlecone pines outlive civilizations, but mountains live longer. The Appalachians are 480 million years old. They were here before dinosaurs, before trees even existed. They've seen continents collide, oceans open and close, and they'll be here long after we're gone, worn down, but enduring. Earth's oldest rocks are 4 billion years old, found in Canada, Australia, Greenland. They've survived everything: erosion, tectonic recycling, meteor impacts. They're witnesses, silent, patient, holding secrets in their mineral grains. Zircon crystals within these rocks contain even older material, tiny time capsules, 4.4 billion years old, almost as old as Earth itself. These crystals tell us early Earth had liquid water. How do we know? Oxygen isotope ratios. The crystals formed in the presence of water. So, within a few 100 million years of forming, Earth had cooled enough for oceans. Life could have begun soon after. We don't know when, but the stage was set early. Earth didn't waste time. Life is chemistry, complex, self-organizing, self-replicating at its core. Life is about molecules, proteins, nucleic acids, lipids, carbohydrates, molecules that can copy themselves, make mistakes occasionally. Those mistakes are mutations. Most are harmful, some are neutral, a few are beneficial. The beneficial ones survive, reproduce, spread. That's evolution. Not a force, not a plan, just chemistry and probability, playing out over billions of years. You are a chemical reaction, temporary, complex, beautiful. Your body replaces most of its atoms every few years. The calcium in your bones, the carbon in your DNA, the oxygen in your blood. You're not the same atoms you were a decade ago, yet you're still you. Continuity of pattern, not substance. You're a process, a dynamic equilibrium, like a flame. The atoms change, but the flame persists. This should be humbling, but also liberating. You're not separate from nature. You're part of it, made of the same stuff, governed by the same laws. When you eat an apple, you're consuming sunlight, stored as sugar, released in your cells. Photosynthesis captured energy months ago. You release it now. Energy flows through you, like water through a river. You don't own it. You channel it. Earth receives 173,000 terawatts of solar energy continuously, more than 10,000 times humanity's energy consumption. It's free, abundant, renewable, Plants capture about 1% of it through photosynthesis, and that 1% feeds nearly all life on Earth. Imagine if we captured even a fraction more, we could power civilization many times over. The technology exists: solar panels, wind turbines, hydroelectric dams, all harvesting sunlight, directly or indirectly. Wind is solar energy. Sun heats the surface unevenly. Air moves. Wind turns turbines. Hydroelectric is solar energy. Sun evaporates water. Clouds form. Rain falls. Rivers flow. We dam them, generate electricity. Even fossil fuels are solar energy, ancient sunlight, captured by plants millions of years ago, buried, compressed, turned into coal, oil, gas. We're burning ancient sunshine, stored energy, but it took millions of years to accumulate. We're spending it in centuries. Renewable energy is returning to the source, harvesting current sunshine instead of ancient sunshine. The sun will shine for 5 billion more years. Predictable, reliable. Why not use it? We're learning slowly. Solar capacity is growing exponentially. In 2000, the world had 1.5 gigawatts of solar capacity. By 2020, over 700 gigawatts. The transition is happening. Not as fast as it should, but it's happening. Earth's future is unwritten. We face challenges: climate change, biodiversity loss, resource depletion. But we also have tools, knowledge, technology, cooperation. Humanity has solved problems before. We eliminated smallpox, closed the ozone hole, brought species back from the brink. When we choose to act, we succeed. The question is, do we care enough about future generations, about other species, about the planet that gave us life? Some do, some don't. But the arc can bend. Public opinion shifts. Policies change. In 1970, few cared about the environment. By 1990, it was mainstream. Culture evolves faster than biology. Ideas spread. Values shift. Hope is not naive. It's strategic. Despair paralyzes. Hope motivates. Earth doesn't need saving. Not really. The planet will be fine. It survived worse. Asteroid impacts, supervolcano eruptions, snowball freezes. Life will persist. Maybe not us, maybe not the species we love, but microbes will endure. Evolution will start again. New forms, new complexity. In 100 million years, Earth could be unrecognizable and still thriving. What we're really saving is ourselves, our civilization, our way of life. Earth is indifferent, but we shouldn't be. There's beauty in that indifference. Nature doesn't judge. It simply is. Mountains don't care if you climb them. Rivers don't care if you name them. They exist independently, magnificently, and you get to witness them for a brief time. A human lifetime is 80 years if you're lucky. A blink. But within that blink, you can see so much, feel so much, learn so much. You were born on a spinning rock, orbiting a star, in a galaxy of billions of stars, in a universe of billions of galaxies. You could have been born anywhere, anywhen, as anything. But you're here now, as you, conscious, aware of the universe, aware of yourself. That's miraculous. Not in a religious sense, in a mathematical sense. The odds were infinitesimal, yet here you are. You're made of exploded stars. Your ancestors were single-celled organisms, fish, reptiles, mammals, primates. You carry 4 billion years of evolutionary history in your cells. In your DNA, you're a continuation of life, of chemistry, of the universe becoming aware of itself. When you look at the stars, the universe is looking at itself. Through your eyes, you are the cosmos, localized, temporary, but undeniably part of the whole. Earth is your home, the only one you have. There's no planet B, not yet. Maybe not ever. Mars is harsh. The moon is lifeless. Venus is hell. Other star systems are light years away. For the foreseeable future, Earth is it. This fragile, beautiful, complex world. Treat it accordingly. Walk gently. Use less. Waste less. Appreciate more. The sunrise. These aren't resources. They're miracles. Temporary arrangements of matter and energy, sustained by physics and chemistry, but also by chance. Lucky breaks in Earth's history. The moon, Jupiter's migration, the magnetic field. Any of these could have gone wrong, but they didn't. And so you're here. Reading this, breathing, thinking. Take a breath, deep, slow. Feel your lungs expand. That's oxygen entering your bloodstream, produced by trees, by phytoplankton. Breathe out. That's carbon dioxide, released back to the atmosphere, absorbed by plants, used to build leaves, stems, roots. You're connected to the forest, to the ocean, to the planet. Every breath is an exchange. You give, you take. That's life, interdependence, mutual sustenance. Look around. If you're indoors, the materials surrounding you came from Earth. Wood from trees, metal from oil, plastic from oil. Everything has a source, a history. Growing in a forest, breathing, photosynthesizing. Now it supports you, transformed, but still part of the cycle. When it breaks, it will decay, return to the earth, become soil. Feed new trees. Asterisk, asterisk, the cycle continues, always. Even you will return. Someday your atoms will disperse, become part of the soil, the water, the air. Future plants will incorporate your carbon. Future animals will breathe your oxygen. You'll become part of new life. In that way, you're immortal, not as an individual, but as matter. As energy. You'll never truly vanish. You'll transform. And transformation is the nature of existence. But that's distant. Right now, you're alive. Here, present. So be present. Feel the weight of your body. That's gravity. Earth, pulling you down, holding you. You're safe, anchored, part of the planet. Listen, if you're outside, maybe you hear wind, birds, rustling leaves. If you're inside, maybe silence, or the hum of machines, electricity flowing, energy transforming. All of it is Earth. All of it is you. Earth is ancient, but also young. 4.5 billion years is long, but the universe is nearly 14 billion years old. Earth is middle-aged. In the grand scheme, the sun has another 5 billion years. So does Earth. Plenty of time for evolution, for change, for new life, for healing. The story isn't over. Humanity is young. 300,000 years. Civilization is younger. 10,000 years. We're children, learning, stumbling, making mistakes, but also learning from them, growing, adapting. The future is uncertain, but it always has been. Our ancestors faced uncertainty, ice ages, droughts, predators. They survived, and so will we. Different, perhaps, changed, but enduring. Earth will outlast us. That's not pessimistic, it's realistic. Every species goes extinct eventually, or evolves into something else. Humans won't be recognizable in a million years. If we're still here, we'll have changed, adapted, become something new. That's not death. That's transformation, evolution. The same process that turned fish into amphibians, reptiles into mammals, apes into humans. The story continues. But tonight, none of that matters. Tonight, you're here, tired, ready for sleep, and that's okay. Sleep is natural, necessary. Your body needs rest. Your mind needs rest. Tomorrow will come. The sun will rise. The planet will spin. Life will continue, with or without your awareness. But you'll be part of it, always. So let go of worry, of stress, of the need to control. Earth doesn't need you to hold it together. It's been spinning for billions of years. It knows what it's doing. Trust the process. Trust the cycles. Day and night, summer and winter, growth and decay. Trust that the planet will care for you, as it has for every generation. You're safe, held by gravity, sheltered by atmosphere, warmed by the sun. Close your eyes. Let the darkness welcome you. Feel the bed beneath you, supporting your weight. Feel the air entering your lungs, life-giving, constant. Feel your heartbeat, steady, reliable. You're alive right here. That's enough. That's everything. The mountains are still standing, rivers still flowing, oceans still breathing, trees still growing, animals still living. The planet continues, indifferent, beautiful, eternal, and you're part of it. For this brief moment, this precious lifetime, you get to witness, to experience, to wonder. Be grateful for the air, for the water, for the ground, for the improbable gift of consciousness, for the chance to see this world, to smell rain, to taste food, to hear music, to love and be loved. These are miracles, not religious, not supernatural, just rare, precious, real. Tomorrow, you'll wake. The sun will have risen without you. Earth will have spun through space, completing another rotation, another day. You'll take your place again in the cycle, in the web. But tonight, rest. Let the planet carry you through the darkness, into morning. You're not alone. 8 billion humans share this rock. Trillions of organisms, all connected, all dependent on each other, on the soil, on the water, on the sun. We're all in this together. Strangers, yes, but family. Children of Earth, made from her substance, sustained by her generosity. Breathe, slowly, deeply. Let each breath be a thank you to the trees, to the ocean, to the ancient bacteria that made oxygen possible. Let each exhale be a gift. Carbon dioxide for the plants. Reciprocity, balance. That's how life works. Feel your muscles relax, your jaw, your shoulders, your hands. Let the planet absorb your worries. She's strong. She can handle it. She's carried mountains, absorbed meteor impacts, survived ice ages. Your stress is nothing. Release it. Trust that tomorrow will come. Trust that you'll face it, but not now. Now sleep. The stars are still there, even if you can't see them, hidden by daylight or clouds or city lights. But they're there, billions of them, trillions, each one a sun, perhaps with planets, perhaps with life, perhaps with beings looking up at their own sky, wondering if they're alone. We wonder too. Are we alone? Maybe, maybe not. But for now, we're here, together, on this pale blue dot, and that's miraculous enough. Let your thoughts slow, like water settling. Let worries drift away, like clouds passing. You don't need to solve everything tonight. You don't need to understand everything. Mystery is okay. Not knowing is okay. The universe is vast, complex. You're small, temporary. And that's okay too. You don't have to be anything other than what you are. A human, alive, aware, present. Rest now. The planet spins, the moon orbits, the stars shine. Gravity holds you, the atmosphere protects you. Billions of years of evolution made you possible. Countless ancestors survived, struggled, loved, so you could be here. Their legacy lives in you. Honor them by living, by resting, by waking tomorrow and trying again. Earth is patient. She's seen everything. She'll see everything to come. You're just one small part, but every part matters. Every species, every individual, you matter. Not because you're special, but because you exist. Existence is enough. Participation is enough. You don't have to earn your place. You're already here, already part of the web, already woven into the fabric. Sleep, traveler. Sleep, child of earth. Let the darkness hold you. Let the silence soothe you. Tomorrow is coming with its challenges, its joys, its mysteries. But tonight, be at peace. Know that you're held, supported, part of something larger than yourself, part of life, part of Earth, part of the cosmos. Good night. May your dreams be gentle. May you wake refreshed, ready to witness another day on this beautiful, improbable, precious planet. May you remember, even briefly, that you're made of stars, that you're connected to everything, that you're exactly where you're supposed to be, here, now, home. Rest well. The earth spins on, and you spin with it, through space, through time, a passenger on a cosmic journey, temporary but unforgettable, unique but connected, human but universal. Sleep now. The universe holds you, always has, always will.